In this video, we will take some stock market data, use Python to produce that data and put that data onto Kafka cluster. After that, we will consume that data and store that data onto Amazon S3, crawl that data to build a glue catalog and analyze that data using Amazon Athena using SQL. So a lot of things to do here, and without wasting time, let's get started. Hey guys, welcome back to the video. In this video, we will be designing a stock market data processing engine using Kafka. So I will divide this video into three different parts. For the first part, we will talk about the prerequisite required for this project. In the second part, we will understand the basics of Kafka and understand the architecture diagram in detail. And in the third part, we will do the actual hands-on practice. So if you are seeing me for the first time, then my name is Darshil. I'm a freelance data engineer. On this channel, we mainly talk about data engineering, productivity, and freelancing. If that is something that you want to learn, then make sure you hit the subscribe button and also like this video if you learn something new from this video. So let's start with the basic prerequisite required for this project. First thing you need is laptop and internet connection because we'll be doing everything on browser, on cloud machine. So make sure you have that. Second thing you need is Python installed on your PC or a laptop and have basic understanding of Python. Anything about 3.5 version of Python works fine, so don't worry about that. And lastly, you will need AWS account because we will be doing a lot of things on AWS such as storing our data onto S3, hosting our Kafka servers on EC2 machine, running crawler and querying that data using Amazon Athena. So make sure you have all of these things set up. If you don't know how to do that, I will put the link in the description. I already have tutorials on all of these things. And for the Python, make sure you have Jupyter Notebook installed because we will be writing our code inside the Jupyter Notebook. Jupyter Notebook is an interactive Python environment. It looks something like this, so you can easily run your code, check the output and move forward. Now there are a few things you need to remember. While executing this project, you will face a lot of errors. And when you face the error, make sure you go online and try to solve it by yourself. If you don't try to solve it by yourself and if you rely on someone else to solve it for you, then you will never learn. So if you don't understand any concept or if you face some error, make sure you go and research by yourself first. And if you still can't find the solution, then ask me in the comment. Because most of the time what people do is when they face some error, they either give up or just write it in the comments and wait for someone to reply. That is not how things work in real world. When you will go in your job, when you face some errors, you will have to solve all of these things by yourself. If you don't understand something, then you can read blogs, you can read books, or you can watch more videos to understand those things. This video will give you the confidence to start your career in data engineering and understand the real-time streaming in action. I will show you how these things work on the concept level and on the execution level. So I hope you have fun executing this project, and without wasting time, let's understand the basics of Kafka and all of the different terminologies that are attached to real-time streaming. So let's first understand why do we even need real-time streaming on the first place. You use a lot of different real-time applications on day-to-day basis. You use Google Maps, Uber, Amazon. All of these applications are real-time basis. So when you order something from Amazon, you get notification of your order confirmation within seconds. When the order gets shipped, when the order is coming to your home, all of these things are coming to you in real-time basis. Whenever the event is generated, it will get sent to you. Same in the case of Google Maps or Uber, everything happens in real time. So these are the basic applications of real-time stream engine. So now what is Kafka? Apache Kafka is a distributed event store and stream processing platform. Now what does this really mean? So let's understand these two things: distributed event store and stream processing. Event is basically when you do something online. So when you click on some application, when you like something, when you share something, all of these things are considered as event. So distributed event store is basically means all of these events are distributed on different networks and coming to you. And then we have stream processing. Stream processing is the act of performing continual calculation on potentially endless and constantly evolving source of the data. So in the simple terms, it is like the flowing water in the river. It is continuous, it is constantly evolving, it keeps moving forward and there is no end to it. So in the real world, when you are moving from location A to location B, each and every step you take, the event is generated and sent to the server. So one of the stream example is the web analytics. So when you use your phone, open some application, click on something, like some tweet, all of these things get recorded and sent to the server. So this is one of the example. Now there are a lot of different application of stream processing. So when you are making some transaction online and if the credit card company finds that this is the faulty transaction, then they will give you the notification in real-time basis. Real-time e-commerce in the case of Amazon. Third is the banking. So we use UPI day-to-day basis, and whenever you make any transaction, you will get the notification in real-time basis. If you receive the notification after 30 seconds or even 1 minute, you will start losing your money because you sent the money but other person did not receive the money and didn't get the notification. So all of these things has to happen in real time. So this was the basics of real time streaming and why we need it. Now let's deep dive into the Kafka. So Kafka has a lot of different components, and one of them is a producer. Producer is basically something that produces data. It is that simple. So we have data coming from sensors, we have data coming from stock market, we have data coming from some web analytics. Whatever you do online, all of these things are considered as a producer. We are producing some data. All of those data are sent to the Kafka server. Then we have a broker, a single member server of a Kafka cluster. So cluster is basically the group of different machines. So in the case of EC2, let's say if you have 10 machines, that becomes one cluster, and one single node or a server is called as a broker in terms of Kafka. So you can call it a server, but in the Kafka they call it as a broker. They have just given one fancy name, but it basically means one server, one broker, or you can also call it as a node. So one EC2 machine, one single node, or one single broker, collection of those brokers are called as a server. So we have a producer, then we have multiple brokers inside one cluster. In our architecture we just have one broker, but you can have multiple brokers and create a cluster out of it. Then we have a consumer. So it is very simple. You have a producer that produces data. In between we have Kafka cluster or a broker. There we write the data, and based on the consumption, consumer can consume that data from the broker. So producer, Kafka broker or Kafka cluster, then consumer that consumes the data and use that data for some kind of activity. So let's understand all of these things in a little bit detail, and this is the technical architecture of Kafka. As you can see over here, we have a lot of different components. So let me just explain you this architecture in very simple manner, and then we will understand the technicality side of it. Okay. So again, as you can see, we have like producers, we have multiple producers, data coming from multiple sources, that basically means multiple producers. Then we have Kafka cluster. Inside the Kafka clusters we have multiple brokers. We already understood. So this can be like one EC2 machine, single second EC2 machine, and n EC2 machine. So inside that we can install Kafka, and that becomes one Kafka cluster. So that is very simple. And after that we have a consumer that is basically consuming data. We can have one consumer or multiple consumers. So multiple producers, multiple servers, and multiple consumers. That is what makes Kafka distributed. Now all of these things are distributed, so we need some kind of manager who makes sure that everything works properly, and this is where the zookeeper comes into the picture. So if you have basic understanding of Hadoop ecosystem, then you will know zookeeper is a resource manager. So in the terms of Kafka, zookeeper makes sure that all of these servers are running properly. So if one broker dies or fails, it will make sure to notify all of the other brokers about this situation and make sure the data is in proper state. Zookeeper also manages the access control list and all of the other security related things and the management. So this is basically the manager of all of the Kafka cluster. That is all you have to understand. Now if you want to understand about Zookeeper in detail, you can read more about it and get better understanding of it. So how Kafka uses Zookeeper: cluster management, failure detection and recovery, storing access control list, and the secret that we already talked about. Now these are the basics of Zookeeper. It is an open source Apache project. It is a distributed key value store. So all of the information are stored inside the key and value. It maintains the configuration information, stores access control list and the secrets, enables highly reliable distributed coordination. So we have multiple servers and brokers working together from different locations. So Zookeeper makes sure all of those servers are working properly and provide distributed synchronization. So all of the data that are getting replicated, Zookeeper makes sure that all of these things happens properly. So we understood producer, consumer, Zookeeper, and the Kafka server. Now let's understand the topics. So topics are basically the logical buckets inside the Kafka broker. So let's understand this by an example. Let's take the case of Amazon again. Now you can create topics for multiple things according to your needs. So if you want to create one topic for, let's say, the order created. So whenever any consumer creates a new order, it will get sent to that topic. You can also create a topic for return order. So whenever someone returns that order, that will get sent to that particular topic. So you can create different section inside the Kafka broker and manage your information properly. So you can do all of these things by creating a topic. So you can create topic for order created, returned order, shipped order, and all of the different events that are happening inside your application. So producer will send data into that particular topic. And on the consumer side, if I'm only interested into the return orders and I don't want to mess with all of the other information, then I can only focus on that particular topic. So topics are basically the logical representation inside the Kafka broker. Now inside each and every topic, you can define different types of partition. It can have 0 partition to n number of partition. based on your requirement. So Kafka topic consists of one or more partition. A partition is a log which provides ordering guarantee for all of the document contained within it. So this is how it actually stores, right? You have your data somewhere, then you have a topic A and topic B, and all of the data are stored inside multiple logs files. So each and every log file is a different partition. So you can have different partition based on a customer ID. So let's say again, in the case of Amazon, if you have like 100 customers, it will have 100 different partitions, and all of the information for that particular customer will get stored inside a single partition. So if you want to access the data for a particular customer, you will just look at one single file rather than scanning through all of the different files. So this might be one of the example. You can also partition it by dates and based on your different requirements. So inside the cluster you have broker, one broker or many brokers. So inside the broker we have topics, and inside the topic we have different partitions, and all of these things are replicated across different brokers. So if one broker fails, you can easily access your data using other brokers. So as you can see it over here, so producer is writing partition A data onto broker 0 and partition B's data onto broker 2, but all of these data are getting replicated inside a different broker. So as you can see, partition A's data is available on broker 1 and broker 2, same with the partition B. So when the broker 0 dies, broker 1 will take its place and all of those data will get written onto broker 1. So this is how it works on basic terms. Again, there are a lot of technicalities behind this, how it works, how Zookeeper decides all of these things. We don't want to deep dive into each and everything because it will take a lot of time. I'll have to create the entire course around Kafka that will be like 10 to 15 hours long. So for now, just understand the basics and move forward, and then you can explore by yourself. So we understood we have data, inside data we have topic, and then all of the topics are partitioned using the log file. So what is log file? Files in which incoming events are returned to the end of the file as they receive. So this is the first entry that comes, then 1 2 3 4 5. So any new event that is coming will get written at the end of the file. So this is how the stream stores the data. You have like data coming first, then all the way to the data coming last, and all of the data get appended to the log file. Now this is the broker basics. We already discussed this, but let's discuss it again and understand it in detail. We have a producer that sends message to the broker. Broker receives and store messages. Kafka cluster can have many brokers, and each broker manages multiple partitions, as you can see it in this diagram. And broker application, we already talked about this. We have partition 0. Data are getting replicated inside multiple brokers in broker 102 and 104. Same for the other different partitions. So we understood a lot of different terminologies. Now let's understood how to do this. So producer basics. Okay, producer can write data as a messages. So you can write your producer in various different languages such as C, C++, Java, Python, Go, JavaScript. Up to you. You can easily do that. Consumer consume data from the multiple topics. So you can also do that using different programming language, or you can have any tool attached to it. So these were some of the key terminologies that were attached to Apache Kafka. So this is a lesson glossary. Okay, we have stream, unbounded sequence of ordered and immutable data. Stream processing, we already talked about, is continual calculation performed on one or more streams. Immutable data basically means you cannot change it. Again we talked about event, broker, cluster, node, zookeeper, and data partitioning, and many more. And this is everything you need to understand to execute this project. Now I will highly suggest you to go online and read about all of these things from a technical point of view and understand more of it. So we understood basics of Kafka. Now let's understand our architecture diagram in detail. So first we have a data set. So don't worry about, I will give you the data set. So we will have some kind of static data set stored in our PC. Then we will write a Python code that will simulate the real-time stock market application. So we will read data from the data set and produce the application that simulates the stock market. Then we will write a producer code that will push those events into the Kafka broker. So over here we have the Kafka already installed on our EC2 machine. Then we will write a consumer code that will consume that data and put that data onto Amazon S3. Amazon S3 is an object storage, so you can store any type of the file you want to store. You can store images, audios, videos, CSV files. Then we will run a glue crawler. This is a service available on AWS. So what you can do is you can crawl the schema out of the different files and build a catalog. This is basically glue catalog, and then you can directly query data on top of different files. So we will run crawler once, and then we will keep storing multiple files, the events that are coming from the Kafka consumer, so that we can directly query on top of those files and understand what is happening. And we will do all of these things in Amazon Athena. So you will understand all of these things in a detail when we actually do the project. For now, just understand the big picture and have the basic understanding of it. And after that, we will deep dive into all of these. So I hope you understood the basics of Kafka. If you did, and if you learned something new, at least hit the like button. That will help this channel to grow and reach more and more people. And now let's start with the actual execution of the project. So I hope you understood the basic concept of Kafka and you already have all of those prerequisites required, such as install Python, have AWS account, and all of the things we talked about. Now we will start with the actual execution. So this is our architecture diagram. We already talked about this. We will start our project with installing Kafka onto EC2 machine, and we will test the producer and consumer on Kafka. Okay, so let's get started with the execution. Let me just go back and let me just open the EC2. So once you log into your AWS account, all you need to do is go to EC2. Okay, you can click on instance over here and click on launch instance. Over here you can give whatever name you want, such as Kafka stock market project. It's up to you whatever you want to give. After that, we're gonna be keeping all of these settings default, as this is like Amazon Linux. We will be using T2 micro. This comes under the free tier, so you won't be charged anything. And you can click on this create new pair. This key will be using to connect to the EC2 machine from our local computer. So you can give whatever name you want over here. Kafka stock market market project. Okay, I already, and then after you give the name, you can click on the create key pair and it will download automatically. I already have key pair on my machine, so I'm just going to use that. Once you download your key pair, or once you download your key pair, all you need to do is create one folder and store your key over there. So as you can see, the key that Kafka stock market project key, this is been stored on my local machine. So once you create the new key pair, it will get downloaded, and then you can easily go ahead. Then after that, keep all of these things as it is. You don't need to change anything, and just click on to launch instance. Once it you can click over here and check your instance is pending. It will take like 1 to 2 minutes to instance to run, and after the status changes to running, we can move forward and start with the actual execution. So now our instance is running. You can see the status over here. Just click on instance ID, click on connect, and you can use this command to connect to your EC2 instance. So even if you are using Windows, you can open your CMD. If you are using Mac, just open the terminal and go to the folder where you have your key saved. So in my case, it was in the document cd Kafka project. If I do the ls, you can see the key over here. It is present over here. Let me just zoom it a little bit. Okay, then you just have to pass this command to yes, and you can connect to the EC2 instance easily. Now if you are using Mac and if you are not able to connect to the EC2 machine, and if you get some permission error, what you need to do, this is just for the Mac. Okay, so let me just go back. Let me just clear. If you get the error of permission denied, you just have to write chmod, okay, 400, and your key name, which was Kafka. If you do this, then you won't get the error of permission denied, but and then you can easily run the ssh command to connect to the EC2 instance. So even if you are using Windows, you won't get any error in the Windows generally, but some Mac users do get this error. So I just wanted to tell you this. So once you are connected to the EC2 instance, then we need to write different commands to install Apache Kafka on EC2 machine and then test some of the things. So we will start with that. So I already created the list of the commands that we want to execute. First, what we will do, we will download all of the required files onto our AWS EC2 machine. So you just have to paste wget command. This will download the Apache Kafka compressed version onto your EC2 instance, so we can use all of those files to run our Kafka server. After Kafka is downloaded, you can just check by doing ls. Okay, now what we need to do, we need to uncompress this. So if you do ls and if you paste it, you can see that we have one folder and we have the zip file over here. Now, as we already talked about, that Apache Kafka runs on top of JVM, Java Virtual Machine. So we also need Java to be installed on our PC. So if you check directly, okay, Java version, you won't find anything. So for that, you need to run this command sudo yum install Java 1.8. If you do this, it will install Java 1.8 on your EC2 instance. Now you can run Kafka on your local machine. So if you have Windows, you can also do that because it is standalone. So whenever wherever you have Java installed, it will run on top of it. So if you don't want to install Kafka, so if you don't want to install Kafka on EC2 machine, you can use your local computer to do that also. But uh, just keeping in mind that everyone uses different OS, I chose EC2 machine, so it becomes much easier for everyone to follow along with me, and also you will get hands-on experience working with the AWS cloud. So now you can just check the Java version and you will see 1.8. After that, what we need to do, we need to start multiple things. First, we need to start Zookeeper, and second is we need to start the Kafka server. And that is pretty simple. All you need to do, let me just clear it, cd, and just navigate to your folder, the Kafka folder that we currently uncompressed. Then you just need to copy this. What we are doing is bin slash Zookeeper start, wait, yeah, Zookeeper server dot start sh, and then this is the config Zookeeper properties. We will talk about this thing in few minutes. Just provide this and this will start your Zookeeper. uh, once you hit enter, it will start the Zookeeper server. Now what you need to do, you need to go to new window with the basic profile and again connect to your EC2 machine, because on one window we will have our Zookeeper running, on the second window we will start our Kafka server, and the procedure is the same. All you need to do is navigate to the same folder that we went. So this is Kafka project, this is where my stock market file is, key file is stored. Go to this, click copy the SSH, just hit enter. I'm connected to EC2 machine. Then if you go over here, what do we have? First of all, we want to increase the memory for our Kafka servers, because so as you already know, we are running our Kafka servers on single EC2 machine. So we want to assign some amount of memory to it. So if you want to read more about these things, you can go online and read it. But you just copy this command and paste it over here, and it will allocate some amount of memory to our Kafka server. After that, what you need to do, you need to start the Kafka server. So again, cd Kafka bin slash, what is the command here, Kafka server start, and our config properties. Let me just paste it. Okay, so it will start our Kafka server. So we have our Zookeeper running, and second we have our Kafka server running. Now there's a problem. The thing is, we cannot use this server, and the reason for that is, let me just find the path. Okay, so as you can see over here, this is the address where our Kafka server is running, and if you check, this is the DNS address where we can use. This is the DNS address that we can use to access our Kafka server. We will be connecting to our Kafka server from our local machine to send data and receive it. Now, if you go to your EC2, let me just go. This is the private DNS. If you can see 172.3135205, this is the private, and you cannot access your private DNS from your local computer unless you are in the same network. So this is the problem. So what we need to do, we need to change this private IP to public IP so that we can access our EC2 machine outside of the network. So that is pretty simple. First, just stop both of these server. Let me just stop it. You can press Ctrl Z, Ctrl C, that works both. Let me just clear it. Okay, we will be editing one file, the file that is config.properties that we were using over here. Now don't worry, I will provide all of this command list in the description, so you can go and check it and follow along. So all you need to do is copy sudo nano config properties, just paste it on one of the server, and this will open this file. Then go back. Okay, over here you need to remove this hashtag advertise listeners plain text colon slash slash your host name. So replace your host name with the public address of your EC2 machine, which is 65.2.168.105. Okay, you can press Ctrl X, Y, and enter, and you can save this. So you can just, let me just clear it. Let me just go to again sudo nano, and let me just check if the changes we made were saved or not. Okay, so we already have the saved version, so we changed it. Now what you need to do, we need to again run the same thing, start the Zookeeper server. once the zookeeper starts. Let me just clear this. Let me just zoom this a little bit. And then start the Kafka server. Now our Kafka server should run on top of the public IP address. So if I scroll up a little bit, let me see if I can find the information. As you can see, our server is plain text 62.21.168.105.9092, which is the port. So we have our zookeeper running and the Kafka server running. One thing also we need to do, we need to provide the security access from our local machine. So over here, you just need to, on your EC2 console, click on to security, click on this security groups, scroll down and click on this edit inbounds. We need to allow the request from our machine to the AWS EC2 instance. So you can click allow all traffic anywhere. I will suggest you to click the my IP. I don't want to click the my IP because it will reveal my IP address over here. So I'm just going to click anywhere, but you can just click my IP and it will work too. Click on the save rules and this will give you the access to your EC2 machine from your local computer. Now, the thing we just did, like edited the inbound rules of the security groups, is not the best practice. You should never allow all the traffic from anywhere in the world because this is not the secured way. And most of the time, when you are working in your company, in your project, the cloud engineer or a DevOps engineer will handle the security part of it. As a data engineer, you are more likely to work onto the data side of building pipelines and use application. But as we are just installing it for the learning purposes, I want you guys to understand all of these things from the scratch. So for the sake of the tutorial, we are not worried about the security part of it because we want to mainly focus on the data engineering side of it. So we have our zookeeper installed, we have our Kafka server, we also edited our inbound rules so that we can access the EC2 instance. Now again we need to create the new window. Again open the new command prompt. If you are using Windows, you need to do the same process. Documents, Kafka project, go to your EC2 connect, copy SSH, paste it over here and connect to the EC2 machine. Okay, so we have two windows running, for the one for the zookeeper, one for the Kafka project with Kafka server, and third one is where we will write some of the things, such as we will create the topic which we already talked about. Then we will create the producer and consumer and see the Kafka in action. Okay, so again the commands are already provided. Cd Kafka, so just go to the Kafka directory. If you do ls, you will see all of those files. Let me just clear it. Then this is the command bin Kafka topic, create topic. This is the topic name. Okay, bootstrap server, this is where you will replace your IP address. So in our case, our IP address is, let me just go over here, copy this and paste my IP address here. Okay, you can do this for all of these three commands. Just copy this, copy this. So one for the creation of topic, second is for the producer, and third one is for the consumer. So what I'll do, I'll just for topic name, this is, let's say, demo test. Okay, you just copy this, just copy this, and I'm going to paste this over here. So this will take some time. Okay, just ignore the warning. What is the warning you get, it doesn't matter. And then the topic is created. So if you see this, then you were able to successfully create the topic. Now what we need to do, we need to start the producer. So again the same thing, make sure your topic name is the same, demo test, demo test. You can give whatever name you want. So just copy this. Again on the same window, we'll start our producer. So as you can see over here, you can type a lot of things. So this is our producer. Now we also need the consumer side of it. So let me just open new window. See, a lot of windows we are opening right now. Let me just zoom it a little bit so that you guys can see. That's very big. Yeah, I need to format this properly. But cd document, same process, Kafka ls. Okay, let me just clear it. Let me go to my EC2 connect. SSH, just paste it, and I'm connected to my EC2 instance. Let me clear it again, and just copy this, the consumer. Make sure you are in the Kafka folder first, and then paste this, and this will start your consumer code. You see a lot of things are running in the backend, so it is starting the consumer server. Let's just wait. I guess it is already started. Let's just start typing. So as you can see, whatever you type, hello world, you will see it over here. Let me just adjust this. Let me minimize these two so that you guys can easily see it. Okay, hello world. You will see we are producing data from a producer, and then we are sending it data. So we are producing data from one end, and then we are able to get that data onto the consumer end through the Kafka server. So if we go back to our this PPT, what we just did, we created the producer. Now this producer we are doing it manually, but we will be doing the Python code on top of it. Then we have the Kafka server, and then we have the consumer. So this middle part of it is kind of over, and as you can see, this is amazing, right? You are getting the data in real time. So whatever you write over here, you will be able to see all of those things in real time. I can write whatever I want, and you will see all of the data coming in real time basis to the consumer. Now this is just a terminal. You can have fun. You can try whatever the text you want. You're feel free to do it. Just explore it, try to see what happens, and once you're done with that, then we can start with our Python code. So congratulations if you were able to complete this project till here, because now we will be using Python code to do all of these things. So we were able to create our producer and consumer and set up the Kafka server onto EC2 machine. Now what we will do, we will start writing the code and do all of these things programmatically. So instead of manually typing all of this data, we will push the stock market data in real time, and we will consume that data, then upload that data onto Amazon S3 and do the further thing. So just open your Jupyter notebook. We already talked about this. All you need to do is click onto this Python kernel 3, and this will start. Give this name as Kafka producer, and open one more and give this name as Kafka consumer. Okay, so we have our producer over here, and we have our consumer over here. Now what we will do, we need to install one package which is called as, let me just pull out the package name, pip install Kafka Python. Now in my case the requirements are already satisfied because I already have installed this Kafka package. But if you are installing it for the first time, it will install it from the scratch. Then you will need to import some of the packages. These are the packages. So I've already written the code, so we don't waste time on manually writing the code, but I will suggest you to write all of this code by yourself so that you will get more hands-on experience. So I'm just going to execute this. What we are doing is we are importing pandas, we are importing consumer and the producer function from the Kafka. We are importing time function, JSON dumps, and importing JSON. You will understand why we imported all of these things. So after you import all of these packages, then we need to create the object for Kafka producer. So at one point we will create the Kafka producer, and another code we will create the Kafka consumer. So let's just put this. So again, this is pretty straightforward. Producer is equal to Kafka producer. We are just using this function. This takes the bootstrap server, so we need to provide the right IP over here. This is the same IP of our EC2 instance because we are connecting our EC2 machine from our local, and that is the reason we use the public IP. Now you guys understand that why we didn't use the private IP and why we use the public IP, because now we can connect to our Kafka server from our local machine and send data. This is a serializer, so we need to send the data into proper format. In our case, we will be sending the JSON data to our Kafka producer. Just run this and you will be able to create the object. After that, we can just start sending the data. So in our case, you just write producer.send. This is our topic name. Topic name was our demo test. Copy it. Set the value. You can give whatever you want, such as hello. Let me just do this. Hello and world, like this. You just hit send, and if I open my consumer code, you will see something like this. So you can send such as name Darshil. Okay, and if you see, we are getting the JSON value over here. So we are sending data from our local machine to the EC2 of the Kafka server, and we are able to consume it. So we can do this on complete loop and easily send it and consume it. So this is the producer side of the Kafka code. Now let's just do the consumer side of it. Again, the consumer is pretty straightforward. We need to import similar packages. Over here you can just import consumer and forget about the producer, and over here instead of using consumer also you can just use the producer. So it's up to you how you want to organize it. Then we have consumer code written over here. So once you import the packages, then we need to repeat the same process. Consumer Kafka consumer, the topic name over here we need to provide the IP address. Let me just copy this, paste it. Okay, and the deserializer. So over here we serialized our data and encoded it into the JSON format, and over here we are just loading it and decoding it into the JSON format. So let me just run this. Okay, so once you create your consumer object, then you can easily loop through it. For C in consumer, print C dot value. Okay, if you run this will start consuming. So if I run some data over here, you will be able to see all of this data. So let me just change it. Let me just name surname. Let me just run this, and you will see all of this data. Whatever you paste it over here, just say if I paste some random keywords, you will be able to see it on the consumer. So the thing that we did with the terminal, you will also see the same thing over here also. So thing that we did on the terminal, we were able to replicate the same thing using code. Now what we need to do, instead of manually putting the data from by ourselves, we can just load the data from some API, some data sets or anything we want, put the data over here into JSON format that will keep producing data and keep sending data onto in one loop. And then we will have consumer who will keep receiving that data and put that data onto some target location. So if you're able to understand how systematically we executed this project, first we started with the basics of Kafka, understood it, and then we were able to install the Kafka onto EC2 machine. We understood how producer and consumer work in real time. Then what we did, we just started with a small chunk. First we connected with the Kafka on the producer side from using code. Second, we did it with the consumer and we connected together and saw the same action that we were able to do it on the terminal. Now we need to just fill the one step. So instead of focusing on this entire architecture diagram, now we will focus on the first two step of it, which is getting the data set and then simulating that data into the real-time format so that we keep getting data in real time. And then what we will do, then we will do this entire thing, which is like crawling, creating catalog and stuff like that. So let's just start focusing on, you can just stop it over here, consumer thing, and then we will start the producer thing. Now in the case if you have access to the real-time stock market API, which is generally paid, if you have some access then you can use that. But in this case we will simulate that data. So we will pick the existing data set of the stock market, and then we will run it in the loop. We will do some sampling on top of it, so we will get some random data, and then we will send that data into one by one to our Kafka producer that will produce that data and put that data onto Kafka server. So in our case, the stock market streaming is basically we are using stock market data and making it into the real-time format. Because not everyone can pay to this API, I just wanted to show you how you can create your own real-time data set to work on the project. So I already have a data set. I will put the link in the description so you can go and use the same data set, but you can use whatever the data set. You can download it from the Kaggle if you want to do that. It doesn't matter what data type you use because it will be the same. You will be able to do it this project whatever the data set you use. So this is what the data set looks like. So this is very small data set. As you can see, we have some index, date, open time, high time, low, close, volume, and all of those things. So we'll be using same data set, index, process. So first we will read this data set and then we will start sampling it, and then we will start putting this data onto our producer code. So first let's read our data. So if you already familiar with the pandas, you will do the df is equal to read underscore csv. Inside we have data and then index process.csv. If I just hit enter, df.head, you'll be able to see we were able to easily read the data. So this is pretty simple. If you know the basics of Python and pandas, you'll be able to do it. After that, I just want to get the random data. I don't want to get this data into the same order. So what I can do is just write df sample one, and this will give me one random row from this entire data frame. If I keep running this, you will see we will keep getting different rows over here. Okay, so I just want some randomness in our data set. So we are not really trying to find some kind of insights from these data. We are mainly interested on the operation side of it, like how the data will go from one side to the next side. So that is the reason we are getting random samples. Then what you can do, you need to convert this into JSON format, so into the dictionary. So to dict, if you do this, this will convert it into the dictionary type format, as you can see over here. And you can also specify orient is equal to records. If I do this, this will be into the proper dictionary. So for index we will have the actual value, for the date we will have actual value. If you don't do the orient, you will see something like this. Okay, we have index, and inside the index we will have some kind of key, and that key will have some kind of value. So we don't want something like this, we just want proper JSON structure. So do this record, and this is inside the list, as you can see it over here. So do 0. So this is one proper JSON or the dictionary format we were able to extract from this data. Now it is pretty simple. All you need to do is put this inside the loop. So while, if you are aware of this, while true, let me just indent this, and then you can copy this producer dot send. Let me just give this name as dict stock. Okay, stock market dictionary. Copy this, paste the value over here, and everything else is same. So let me just run this, and while this is running, let's just open our terminal window. Where is my terminal? So as you can see, we are getting this data into real time. So you are able to see that from the one source you are inserting this data into real time basis, very fast, row by row, and you are able to get this data onto the next end. So we send a lot of different data into the small amount of time, and that broke our entire server. So as you can see, the broker is not available, Zookeeper went down, our Kafka server went down, because we are running this Kafka server on very small machine, and we are just using one single broker and one single partition. So it is not able to handle all of this data at this scale. If we want to do that, we want larger machine and distributed computing, but we will understand all of these things into the future videos when we do the more detailed tutorials. But you're able to see all of these things in action. So when you run the code, you can see how the data is moving from one source to another source. So if this happens, I mean, just if the server breaks on your side, all you have to do is run it again. Let me just start the server. So start the Zookeeper, start your Kafka server, and then you can start the consumer. So again, so if your server breaks again, you can start the Zookeeper again. You'll have to start the Kafka server again, and you can start the consumer. Let me just run it once again. If you are able to see the data, let me just stop it again. We don't want to again overload the server with a lot of data. So you can see all of those same JSON data we are getting. So that's pretty cool. We are able to see how all of these things happen behind the scene, just like your current location is going on the rapid phase. So when you're traveling from one location to the destination, when you're using Google Maps or any app such as Uber, Ola, or whatever you use, you get the live location. So all of these events are going from your location to the server and coming back in the real time basis for you to give the final result. So we were able to produce some data. Okay, now what we need to do, so if you print the consumer on the code, you will see the same data available over here also. So if you want to remove all of this data, that is pretty simple. Write producer dot flush. This will flush all of the data, and now if you print this, you will not get anything. So it will empty the entire buffer, and then you can again send the new data if you want. So if you want to remove the old data, you can easily do that. So this was more about the producer side of it. So we were able to complete this and this. Now what we need to do, we need to work on this part of our code. So Amazon S3 crawler glue, and then we will see some real-time data coming onto Athena side. Okay, so let's keep going forward. Now what you need to do, you need to go to your S3, go to your AWS console, click on S3 and create new bucket over here. uh, Click on to create bucket. uh, Make sure your bucket name is unique. throughout the AWS universe. So you cannot use the same bucket name whatever I use, because you will not be able to use it. So give a unique name, Kafka stock market tutorial YouTube, and then you can attach your name. So in this case, if I attach Darshil, you can attach your name and it will automatically become unique. You can again use the same region nearest to your location, and then keep everything as it is and just click on to create bucket, and this will create the bucket Kafka stock market YouTube. Let me just go to this bucket, and this is my S3 bucket. Now if you don't know what S3 bucket is, I will suggest to watch some tutorials. I already have it on my channel. But S3 bucket is an object storage. You can store whatever the type of file you want. You can store audio, video, movies, CSV files, Avro files, ORC files, and whatever that you want. So you can store. This is the object storage, right? So we have the object storage. Now what we want to do, we want to upload data from our code, okay, to the S3 bucket. And for that we have a package called as S3FS. So you can do pip install S3FS. I already have the requirement satisfied, but if you don't have it, you can just install it. You also need to configure AWS in your local machine. So the way to do that is basically you need to go to IAM. Okay, so when you created your AWS account, you might have got the AWS secret key and the access key. But if you don't have it, or if you forgot about it, then what you can do, you can go to user, click on to add user, just give the name like Darshil admin account, click on to access and programmatic access key and the programmatic access. You can also give the AWS management console access, but in this case let's just keep admin program programmatic programmatic access. Okay, let's just give this, let's just give next, to next, review. Okay, oh, let me go previous, go back over here. You need to attach existing policy, so click on to add administrator access. Okay, go next, next, create user. This will download one CSV file. This file will have my access key ID, as you can see it over here, and the secret key ID. Make sure you do not leak your access key and the secret key. So I will not show you over here, but this is where you will have this downloaded, and this will download only once. So make sure you properly save it somewhere. After you save it, all you need to do is go to your terminal again. So let me just open one of the terminal. I have so many terminals open right now, around 1 2 3 4 5, and this is the sixth one. If you don't have AWS CLI installed, all you have to do is go to AWS CLI onto Google. You can install it. If you have Windows, let me just show you. If you have Windows, you can install it over here. If you have Mac OS, you can install it, and if you have Linux, you can easily install it. So once you install it, all you have to do is go to CMD AWS configure, hit enter. Over here you will provide your access key ID. So just copy your access key ID from your CSV file and paste it over here. Just hit enter. Provide your secret key ID over here. So whatever your secret key ID is, just paste it over here from the file. I already have it assigned, as you can see over here. Then your default region, whatever the region you are using over here. So on the EC2 side, I'm using Mumbai. So AP South 1, this is my region, but it can be changed based on your location. So whatever region you are using on your AWS, you use that. Hit enter, and you are done with your AWS account setup on your local machine. So once you do that, then you will be able to send data from your local machine to S3. So once you install S3FS, we already did that. Right, just write from S3FS import S3 file system. Let me just run this again. Okay, now let's just comment this code for now. We don't want to do anything. So what you need to do, first create the object S3FS same. Okay, I just run this. So now what we really need to do, for each and every different row, we want to create a file and store it on S3 bucket. But we also want to give the file unique name each and every time. So what we will do, we will assign the numbers at the end of the file and then store it. So this is how it works. We will use count and I in enumerate in enumerate C. This is our consumer, C consumer. Okay. Now this is the Python function. This basically means you will get the count. Okay, the count, and I is basically your the actual uh, iterator on the consumer. So if I do this print count, and if I do print I, so if we run this and if we process some data, let's just send some random data over here, you will see count 0 and some data. Let's just run this again. You will see 1 and some data. If I run this again, you will see 2 and some data. So what it is doing, it is iterating and increasing one count every time it gets new data, and also printing the value. Now we can use this easily and store our data onto S3. What we really need to do is, okay, so write something like this. So here you need to provide your so here you need to provide your S3 bucket name. So let me just copy this, paste it over here, slash, this is my file name. Okay, and this is where I will put the count value as it is. File I dot value, this is the actual value that I want to put, and this is my file object over here. So if you understand basics of file creation in the Python, you will be able to do that. So let me just flush this again once more, and let me go back and start my consumer. Just stop this, and I will run this, and I will also run this for 1 2 3 4 5. Okay, for the 5 second I ran this. Let me just stop it. Let's just stop our consumer also. We don't want to keep running it because again our server will fail. If I refresh this, I will be able to see some data over here. As you can see, we have a lot of different, like, stock market JSON 1 2 3 till 100, and in just like 5 seconds we were able to produce a lot of data. So if I just click on it, download one of the file, and let's just see how it looks. Let me just open this over here. So you will be able to see one single event is available in this file. Okay, so this part is done. Let me just go back to architecture diagram. We were able to upload some data onto S3. Now what we need to do, we need to build a crawler, AWS glue catalog, and Athena. So let's just do that. If you guys are finding this video helpful, make sure you hit the like button and subscribe to this channel. This helps a lot. I mean, you guys are seeing like this the creation of this video takes a lot of time. It is around like 12 a.m. right now, 12:30 a.m. of the night, and I'm still recording this video at around 11 p.m. It is around 12:30 a.m. So make sure you hit the like button to support this channel, and let's just go forward with that. Okay, also let me have some water. Okay, let's move forward. So what do we want to do? We have data onto S3. We need to write a crawler. We already understood what the glue crawler is, but let me just again explain this in the brief. The crawler, what we will do is we will crawl the entire schema from our S3 file, so we can directly query on top of it using Athena. So this glue crawler, I'll just call it crawler. Okay, click on this. Okay, so just click on this crawler, click on to create crawler, give unique name, stock market Kafka project. Okay, project, keep everything as it is, click on next. Is your data already mapped to glue tables? Not yet. Add data source. Inside our data source, we want to this is optional, we don't want to do it over here in this account. Select your S3 bucket. In our case, S3 bucket was, oh shit, let me just open it. S3 bucket, Kafka. This was my S3 bucket. Let me just copy the name as it is. You can paste it. Just select this and choose, and just put the slash over here. So we want to run crawler. So we want to run crawler on the entire S3 bucket. Okay, just keep everything as it is. Click on add S3 data source, click on next, IAM option. In my case, I already have the IAM ready. IAM role is basically that gives access to the services. So in our case, when we wanted to access AWS S3 and upload data on top of it, we had to configure all of those AWS secret key and access key on our local machine. Now, if these services such as Glue wants to talk to S3, you need IAM role. IAM role will give access to the Glue to write all of those data onto S3 bucket or read data from it. So if you don't have IAM role, or you can go to this new tab, just open IAM. Okay. Let me just put it over here. Click on to roles. Click on to create role, AWS service. Over here, select your service name. In our case it was Glue, so let me just Glue. Okay, click on the Glue, click on next. For now, just give the admin access, so just write admin and you'll be able to see administrator access. This gives full access to AWS services and resources. Just click next, give name such as Glue admin role. Click on the create role and you'll be able to click create the entire role. I won't do it because I already have roles created. I'm just going to use one of the role I created for the YouTube project. If you have done it, you will remember that, so I'm just going to use that. Okay, let me just use it again. Then keep all of these things as it is. Let's just create the new database on over here. Let's just give the database name as stock market Kafka. Just click on to create database. We have the stock market Kafka database available. Choose the data set, just refresh it. Stock market Kafka. Keep everything as it is and click on next. Everything looks good. Click on finish. This will create our crawler. This is ready. Click over here and click on run. This will start the crawler running, as you can see, and let's just wait till the crawler finishes, and once it is finishes we will see the next step. So crawler is almost finished, as you can see over here, and you see one table changes, so you can see it on the it is succeeded. Okay, let me just sort it properly. No. Okay. Okay, this is the our crawler. So let me just go to Athena. As you can see over, just write the Athena and you'll be able to go over here. Let me just close all of these previous queries. Now if you refresh this, if you go AWS catalog, stock market Kafka, and you will be able to see one table, Kafka stock market tutorial. If you click on the preview, you'll be able to see all of this data over here. Okay, we have around 10 rows right now. Now if you get some error while doing this, while querying this, it is not able to find some target location, all you need to do is go to settings, click on to manage. Over here you need to provide some kind of S3 path where it can store this temporary query. So if you don't have any extra bucket, you can create the extra bucket and store it. If you have, or if you already have the bucket ready, just click on it and it will be good to go. So I already had the one Glue temporary bucket, I just store it over there. But if you don't have extra bucket, just create the extra bucket for the Athena queries and it will store all of the temporary results in that bucket. So make sure you create the bucket in the same region, else it will not work. So right now we have 10 rows. So let me just go back to architecture diagram. So what we have, we were able to upload data onto S3 crawler, Glue catalog, we created it and we can easily query on top of it. So we kind of completed our entire architecture diagram, but we are not able to see the real-time data right now. Okay, so we are not able to see the magic of real time. So again, so we were able to do it, but we are not able to see this action in live. So what we need to do, we need to again send some data in real time, because we are not sending data right now and we are not able to retrieve that data in real time. So what we will do, we will add some delay so we don't overload our server. So we will add delay of 1 second. You just need to do time sleep 1 second. Okay, we already have the sleep, so instead of doing this, you can just do sleep 1 and just run this. This is sending data onto your producer, and if we run this, we are consuming data and uploading data onto our S3. So if I go to my S3 bucket, let me just go to S3. I go okay, I already have my bucket. So currently what do we have? Around these many rows. If I run this, I will keep getting more and more rows over here if I keep running it. Let me just go to over here and let me just run count. Okay, and let's just see how many rows we have. We have 631 rows. Let's just wait for few minutes. 731, we are running it. 789, 861, 921. So as you can see, we are getting data in real time basis. So from our producer we are sending data at each and every second. From our consumer we are getting this data and we are uploading this data onto S3 bucket. All of these files, as you can see over here, are coming in real time basis every second, and we are able to query this data into real time using this Athena. So if you keep querying it, the count keeps increasing it every second. So like 1494, 1576 and stuff like that. And if you just print the entire data, uh, if I just run this, this will scan the entire data. As you can see over here, you have like a lot of different data. 93 milliseconds it took. This is the entire data scan. If I do, let's just say, if I do, what do I do, max of date. Okay, max of date. If I run this, I will get 28.5 or something. If we have more max date, then it will automatically change, but right now we are not getting it. So let me just do count again, star. Let's see how many rows we have now. We have 2600 rows, around 608. If I run this again, 2.7. So I mean, you get the idea, right? What is happening? We are sending data in real time, we are getting data in real time, and we are able to query this data in real time. So we were able to get the idea of how these things happen in real time. We have data over here. Okay, we are simulating this data using the existing data set using Python 3. Then we are sending this data using producer. It is going inside the Kafka, going inside the consumer, S3, crawler, glue, and Athena. So we don't have to run crawler because crawler has already ran and created the catalog. So we can directly query on top of it and get the real-time result in Athena table. We already discussed all of these things in the start of the video. So you were able to see these things in action. First of all, congratulations if you were able to reach till here and completed this project, because most of the people might have given up in between because they got one error and they are not able to solve it. So again, they are trying to find the easiest path, but you didn't do it. You completed this project till the end. So if you completed the entire project, so let me know in the comments by writing I completed this entire project and I'm excited to learn more. That way I will know that you actually completed this project, because not everyone will comment that thing. And if you see that comment, make sure you reply to that comment and tell other person congratulations. This was the entire project that I designed, but you can modify this project according to your requirement. So I just gave you the kickstart to the Kafka. Now you can go do more Kafka courses. Again, everything is free on YouTube. I will create my own courses in the future. So for right now, you already have the tools. Go online, learn more about it. You can modify this architecture according to your requirements. So instead of using the simulated version, you can actually use the real-time API. Understand how to integrate real-time API with the Kafka producer. You can go online, you will find a lot of resources. Okay, then on the consumer side, instead of pasting data onto Amazon S3, you can directly push the data onto Snowflake database, BigQuery, or whatever you want, or you can directly visualize that data onto some using graph. So up to you how you want to design this architecture according to your requirement. So congratulations on completing this project. I hope you had fun executing this project and you understood and learned something new, because very few people will be able to do this and you are one of them. So congratulations with that. So this is just a start of your data engineering career. I'm planning to build more and more different types of projects and build courses around it. So if you want to learn all of these things, then all you can do is just subscribe to my channel. You can also follow me on LinkedIn or Twitter if you want to get more updates on this. And I hope to see you in the next video. Thank you for watching and have a good day. Bye.